chapter 1, 45. Well, that's that kind of open-ended thing. Let's see. Yeah, let's do one of these together. Shoot, I get it all set up. I don't think we did one of these together yet. I always try to do one of these problems. I am just working against myself today. It's really exciting. All right, so this is I'll put it up here in case you were bookless today, which I don't blame you. I just put you some play back. This is section 1.1 homework. Yes, about 45, but I'm going to do something else. Just to show you how these are supposed to work. Oh yeah, 87. Okay, this is the one that you just have to read the section. There's a lot of terminology in section 1.4. You just have to use each term correctly in the context. So real quick, since I have this right here, listen. Number 87 gives you a setup of an experiment for truck drivers and such. Right? Don't talk to me about sample, proportion, all that kind of stuff. That's not section 1.4. Go to section 1.4, read it, look at the terms, and then use them correctly in this context. Are you guys? I have a feeling that not everybody has even tried that yet, so I'm not going to say a damn thing about that yet. You have, I'm sorry. Yeah, yes. Yes. Or variable, all of that stuff. No. You use, I'm not going to give you a hard set number, but use enough of the terminology in relation to that setup. So if you read through the section, you'll see what it's all about. It's about experimental design, placebo, double blinding stuff. Double blinding, for example, is when neither the person being tested nor the researcher knows who's getting what, just to make everything absolutely above board. All right, so let's go back to let's do the first one, I think. I don't think I signed 42. So this set of homework is a little bit strange. If you tried it, you know what I'm talking about. It says, for all of these, identify all of these. So sometimes I'll have somebody give me population sample. No, that's not what it's asking. For this problem, number 42, what's the population? What's the sample? What's the parameter? All of these things. All right. And the thing is, they don't give you a sample. You just give me a representative. So for this first problem, a fitness center is interested in the mean amount of time a client exercises in the center each week. What's the population? Yeah, and you can use the same language they have.
Oh, the fitness center.
Fitness center clients, all fitness center clients. That's the population. You guys with me? Okay, I like it. Then you move on. What's the sample? So here you can give an example. Give examples where appropriate. What's the definition of a sample? You can kind of use definition wording. Huh? Good. So like a subgroup of the population. You guys with me? So you could be really boring and right here just say a subgroup of the clients of the fitness center. Yes, that's fine. I'm not shitting on that. That's fine. You can do that if you want to. Or you could be a little more. You can say 97 randomly selected fitness center clients. Right? Ooh, that's so much better. Ooh, that's so out there. Do you guys understand? That's what they mean by give examples where appropriate. Hopeful. You guys still with me? So each one of these problems, none of them have a sample explicitly stated. You just come up with a sample that would make sense. Now remind me. So we've identified what the population is. Let's say that we say the sample is 93 selected fitness clients. Right? What is the parameter got to describe? Yeah. Is the parameter a group of people or things? Is the parameter a group of people or things? I love you guys. I love you guys. What's the population? What's the population? It's the entire what? No. In general. In general. It's all of the items or people that we're interested in, right? Okay, I like it. What's a parameter do with that? What's a parameter do? What's a parameter? Parameter describes a population. How? Doesn't list their names. Say what kind of thing about them? Very important, huge part of this definition. It's a numerical description of the population. And what's the statistic? A numerical description of the sample. Stay with me, come on, guys. So, however the hell you answered part A, that better show up in freaking part C. Because what's part C supposed to describe? The population. So what do we say about the population? All fitness center clients. All of the fitness center clients. So what would the parameter be? You could do it. What would the parameter? What are they interested in about those fitness center clients? Yeah, there you go. The mean hours, the mean amount of time that which clients? All fitness. Oh, see how the population showed up in your parameter because that's what the parameter is supposed to represent. This is not huge. This is very simple. You got to have the wording about your population show up in the parameter because that's what parameter does. But what is a parameter? A parameter is always either a mean or a percentage or maybe some other stuff that we'll talk about later. It's a numerical description of the population. So it's going to be an average or a percentage. Almost all the time it's going to be one of those two things. If you don't say that in your answer to parameter, you are wrong because it's got to be a numerical description. Maybe. So what about the statistically? How would the wording for these compare? What does the statistic do? Description of the sample. The same way the parameter is the description of the population. So the parameter was the mean amount of time that a client works out, that all clients work out in the fitness center, right? So what would the statistic be? The mean amount of time that the 93 randomly selected clients work out in the fitness center. They're going to be exactly the same because they both do the same thing. They both describe a group of clients of the center. One describes all of them, the other one describes a subgroup. So they're going to be exactly the same wording. Just one of them says all clients, the other one says subgroup. Maybe. And then what about the variable? Who remembers what the variable is related to? The question that you're going to ask. So you have a group of people you want to say something about. You have a group of people you actually talk to. What are you going to talk to them about? That's the variable. So what is the variable? What are you going to ask each person? That's crazy. How long do you work out in the center, right, each week? So that would be the variable, the amount of time that a client works out in the center each week. And then the data is where you give examples for sure. Give me some examples. What's the data? The variable is the question I asked. The data is the answers I get. So just give me some answers somebody can tell you.
5 minutes.
5 hours is crazy. 7 hours. 0 hours. I just like to go there and talk and then leave. I think that's true about some people. It's freaky. I go to the gym. Do you work out? No? Yes? Okay. If anybody goes to the gym, there's people that are there no matter what time of day it goes. The same people. I'm like, you live here. Stop. Yes?
For these questions, could the data be random? Like, or do we have, like, how would we go about writing it?
Just like we just said.
Because you came up with, like, 93, but that wasn't on there, so it's just anything.
Exactly. That's why it says give examples where appropriate. So you could, for the sample, you could use basically like a definition approach and just say a subgroup of all the clients.
So it's only just to help explain.
Yes, to make it a little more definitive, you could just kind of give an example of what a sample would look like.
Okay.
That's why I just said 93. But your answer to that could be just a subgroup of fitness clients. That's more like a definition approach, right? Okay. I like it. So this problem is a little freaky, but I love this problem. Once you kind of see what they want from you. Okay. Anything else about, hopefully that helps out, Alyssa. Anything else from homework stuff? Homework stuff. Okay. All right. Okay. So let's get back to, let's get into the next stuff. Sleep. I think so I gave you that histogram answer key from that handout we did last time. So obviously if you have questions on that, you could ask. I'm hoping histograms are relatively straightforward. The one thing that freaks people out is the class width and how that shows up in the table. You guys with me? That's the one area that's a little bit freakadelic, but hopefully that makes sense. So we're about to get into a little more analysis of the data. So far we've been talking about how to show, how to represent the data that we get. Now let's look about how to analyze the data. Has anybody ever taken the SAT? Yes, a few of you guys. When you get your results, do they still give you a percentile? They should. Like you're in the 90th percentile for math and the 30th percentile for reading or something. Which one of those would you be concerned about? 90th percentile for math, 30th percentile for reading? Yeah, what does 30th percentile mean? What is the 30th percentile? What the hell would that mean? Yeah, you only scored higher than 30% of the other people. I really want to say this again because there's going to be a lot of questions in the homework that say something like, Joe is in the 60th percentile for lifting weights. Is he happy or sad about that? You have to interpret what that means to answer the question. So if you're in the 30th percentile of anything, that means you're higher than 30% of the other people. Your score is, or whatever it is. Is this always bad? No, not necessarily. This is good for golf. This is good for running times in a race. Don't you want your running time to be smaller? Right? That means you went faster. You guys kind of with me? A little bit? Okay, so 30th percentile, one thing is it looks like this. This is the symbol for 30th percentile, P30. And it means that 30% of all others scored, I'll put scored lower. Whatever it is I'm measuring, they got lower than you. So it'd be much better, of course, to be in the 90th percentile in terms of a grade or something. Okay, I like it. Why do we do this? If you get a 90th percentile on the SAT, does that mean you got 90% of the answers right? No. In fact, you could have gotten almost everything wrong, to be honest, as long as more people got more wrong than you. I mean, 90% of the people must have gotten more wrong than you. Are you guys kind of with me? So my first test grade in grad school, I got a 21 out of 40, which I thought, that's barely above 50%. So I thought, what am I doing here? Holy shit. And then the teacher later said, good job on that, Jeff. And I'm like, what are you talking about? Because I think the highest grade was like a 23 out of 40. You guys with me? So the percentile gives me a feel for how I am relative to everybody else. So do you guys know what they do with the SAT? Every time after it's done, what do? The next time you take it, is it going to be all the same questions? Do you guys know anything? Do you guys know what the SAT is? Yeah. Okay, all right. So why do you think so? So of course they have to change the questions because you're allowed to retake the SAT. But what does that mean? And plus, they don't want people somehow taking information out about the test for other people. But if they change all the questions, what could they happen to randomly do in terms of the difficulty level? They can make it easier or harder. So then everybody should do better or worse. So it wouldn't be fair to give an absolute grade. right? Because you're like, I got a 70 on my SAT, you got a 72, you did better, No, the other guy might have done worse relative to everybody else, right? So this relative measure is better. Yes, okay, I like it. So, let's get into some nitty-gritty actual data. Here, let me make, so a lot of the stuff we talk about with percentiles make more sense with a larger sample. I'm going to make a smaller sample just so we can make sense of the procedures we use. Cool? So let's see. You guys are all like, just do what you're going to do, man. How many is this? 1, 2, 3, 4, 5, 8, 9, 10. There we go. What's one nice thing I did here that you got to remember to do? Order. If they're not in order, you can make anything you want. So they got to be in order. I like it. So there's 10 numbers up here, right? Which number do you think represents the 80th percentile? Knowing what that means. 19 worries me a little bit. So 80th percentile should have what percentage below it? 80% should be below it, right? So it seems like that would be, which one? So I got people telling me 47. Any other possibilities? 50, okay, I like it. This is kind of a trick question, of course. Right? If you're in the 80th percentile, there should be 80% below you, which means there should also be how much above you? 20%. 80% of 10 is 8. So which number has 8 data points below it? This one does. You guys with me? Don't freak out. We're developing a process. We're showing why this very, very simplistic view isn't quite right. So we can make sense of what we do. Which number has 20% above it? 47. So there's no data point that does both things. So what do you think would make sense? I want to get a number that has 80% below it and 20% above it. So what do you think you could do with these? Average them. I love it. So take the average. Kick ass. Right? So the first step you guys kind of naturally did, was you took 80% of 10. Even if you didn't think of it that way, that's basically what you were doing. Which makes sense. How do you get to the 80th percentile if it's supposed to have 80% below it? Well, you go 80% of the way in. So you've passed 80% of the data. That makes sense. It's a good first step. So P80, the first step would be 80% of, why is it 10 right now? Because there's 10 data points. So please change that if you get 38 data points. Don't just always make it 10. So what is 80% of 10? 8. It's crazy. Now, here's the thing, though. Here's the step. Here's why this next step makes sense. I know the 8th number is not the answer. So whenever you do this first step, you take 80% of 10, and if you get a whole number for this first step, then you take that number and average it with the next one. So the answer is not the 8th number, it's the average of the 8th and 9th. I like it. And what do you get when you average the 8th and 9th number? 48 and a half, I like it. I like it. Okay, I like it. Cool. Now, let's do another one that doesn't come out to a whole number. If it comes out to a whole number, then you average that number with the next one up. Anytime you do this first step. So let's do another one that comes out the same way. What about P60? What's the first step for P60? Take So first step for P60, take 60% of 10. Why 10? Because I happen to have a list of 10. What's 60% of 10? 6. That's crazy. So then I take what? I take the average of the 6th and 7th. Why do I do that? Because that's a whole number. I like it. So I average the 6th and 7th. And what do I get? What's the 6th and 7th? 1, 2, 3, 4, 5, 6, 7. Hey, that's a nice one. What do you get when you average these? The answer is? Thank you. Life, the universe, and everything. Question, of course, is what is 6 times 9? I don't know if you read that book. Huh? No. If you read all the series, you would see that's the answer. That's the question for the ultimate answer. So let's do one that doesn't kind of follow that pattern, where it doesn't come out to be a whole number. What about P34? Try to figure this one out. That what would you do first? 34% of, that's crazy, right? You get 3.4. It's not a whole number, so what you do when you get any decimal, I don't give a shit what it is, you round up and you take that number. So if you round that up to the next whole number, you get 4. So the fourth number is the answer. What's the fourth number? 18. That's the answer. Yes, ma'am?
Do you always round up?
Always. If it's a decimal, if it was 3.07, you round up to 4, take the fourth number. I like it. The book has a much more complicated formula, which if you want to use it, you can, but it's complete shit. Right? It's too specific. If it's a very small set of data, you're going to have a lot of repeats. Let me see if you guys get this. P34 is 18. What would P33 be? A freaking teen, right? What about P32? 18. What about P37? 18. Why is 18 so many things? Because there's just a few data points. There's only 10 of them. If I had 8,487 data points, then almost everything would have a different number to it because there's a lot more data. There's a lot more plate. It fills it all in much better. Here, there's huge gaps. Maybe. So what I want you guys to do right now, figure these 3 things out. P25, P50, P75. For that set of data, that same set of data. What's up?
The GP?
Yeah. They were aware of it the other day. They should still be aware of it now. A little thing. That's going to be annoying. Oh, put that there later. All right, let me catch up to you guys. P25. P25. What would be another good name for P25? Thinking about the Super Bowl yesterday, or if you don't like football, think about basketball. If you don't like any sports, think about any 25% of the way in to anything would be, what's another name for that? A quarter of the way in. So another symbol for P25 is Q1, first quarter. So unbelievably, this would be, no way. And then this would be, so that's another name for P25. Another name for so forth, right? What's the first step here? 25% of 10, which is 2.5. So you do what? Round up. The third number is the answer. So I always like to say the first step of these is where the hell's the answer. The second step is go get the freaking answer. So if you don't do the second step, you just put this number down, that's crazy. Here's no 2.5. Right? What is the third number? Crazy. P50, Q2 is also its name. So I take half of 10, which incredibly enough is 5, and then I do what? Average the fifth and the sixth. So anytime you come out to a whole number, you just average it with the next one up. Why does that make sense? Because of everything we did in the first place with that data. What we do makes sense based on what we did in the first place. So I average the fifth and sixth. What's the fifth and sixth number? 1, 2, 3, 4, 5, 6. So here and here. Yeah, when you add them, you get 60. Then divide by 2. You get 30. Where am I at? I like it. Everybody cool with that? Everybody all right? Yes.
So if like the number you get is not a whole number and you have to round it, do you just take that number and that's like the answer?
No.
Or do you still have to take it?
Anytime it's a whole number, you average. I think you said it right actually. Now that I hear, anytime it's a decimal, I don't care what the hell the decimal is. I don't care. You round it up, take that number. If you get a whole number, you have to average it with the next one. So you sort of secretly hope you get decimals, because then you just round it up, take that number, you're done, right? So here, P75 is going to be 7.5. Is that cool? Round it up to 8. So the 8th number is the answer. 47. Kick ass. Kick ass. And then we can, yes?
I still don't understand how we got 30 for the second one.
So half of 10 is 5.
Yeah.
You got a whole number, so you have to average that with the next one.
So that would be
1, 2, 3, 4, 5, 6.
41.
So you average the 5th and the 6th. Is that anytime you get a whole number, you average that with the next one. So I got 5. I'm going to average the 5th number with the 6th number. So I'm going to average these two.
By adding then dividing by 2.
Yes.
All right. Okay.
Yeah, that's how you find the average of any two numbers. Or you could just figure out the middle if it's easy to do. Like we figured out the middle of these two easy enough. I didn't have to add them or shit. But 19 and 41, a little bit harder to think in your head. Are you guys cool with, watch this. 19, go up 20, 41, go down to 40. What's in between 20 and 40? 30. There. I didn't have to do an average. So there's other ways to do it, but the quickest way is add and divide by 2 if you're not sure what to do. All right. How's everybody doing? All right. All right. Now we're going to create something that it sounds like I made up this name myself. It's called a box and whisker plot. You see this all the time. Once I create it, I'm almost certain that all of you have seen this kind of thing somewhere.
How often do we use these in more advanced statistics plots?
Say one more time.
How often are we going to use box and whisker plots? Like how much before?
Holy shit. Depending on where you go, if you're going to anything science related, all the damn time. If you're going to anything business related, often enough. Right? If you're not doing any of those two things, for this class. Right? I like it. How often do you see them? A lot. You see them for any data analysis that somebody does, they could represent something with a box plot. So let's create it and then see if you can see the usefulness of it. And even if you can't, you still got to be able to do it. Okay. So to do a box and whisker plot, I need what's called, I think the book just calls it a box plot. I need what's called the 5-number summary. Thank God we basically have that already. Here's the 5-number summary. How do you summarize a football game? It starts, end of the first quarter, end of the second quarter, end of the third quarter, and then it ends, right? There's 5 interesting points. You with me, especially yesterday. So there's a low data point, the first quarter data point, the second quarter, the third quarter, and then the highest. And we have all this shit, right? What's the lowest data point? I erased it, but you've got them written down. What was the lowest data point? 4. And then we got these figured out right here, 15, 30, 47, and then the highest data point was? 54. Kick-ass. Okay, I like it. And then here's what you do. Let me really try to make this unbelievably clear. One of the worst things you could do when you graph anything is to have an inconsistent scale. Let me show you an example. Here's a quick way to make your math or science teacher cry.
You said it wasn't going to be a straight line.
Okay, anybody see what's wrong with that shit? Is there anything wrong with that? Please. 2 things wrong. I didn't tell you what this scale is, but pretend like you have this scale okay. What's wrong with that? What's wrong with it? Huh?
The scale's not even.
Yeah, scale sucks. So here you said it was 10, and then you did 5, and then you did 33, and you did 1. What the shit? Everything's going to look like a straight line if you just kind of put the data points. No. So what do? You set up a scale where the data points all have a place to go. You don't set up the scale based on the actual values. You set up a scale that has a place for everybody. Sort of like classes. Right? So where do I want to go from to then, maybe? I've got to go from 4 to 54. So it's up to you guys. Huh? We don't want to start at 5 because then 4's got nowhere to be. So maybe this time, for this one, we could do 0. And then go by... It's up to you. We can go by 10s, by 5s. We can go by 9s. We'll go by 10s. 0, 10, 20, 30, 40, 50. I like it. I need a 54 though, don't I? You guys understand the importance of that? If your scale is not consistent, then you could be manipulating the data. You could be being dishonest. So you don't want to do that. And now what you do is this. You put a line over each of the data points. So where's 4? 4 is roughly right there. 15 is right between these guys. 30 is right there. Thank God. 47 is almost 50. And then 54 is... got it. Right about where that was. That's exciting. And then here comes the box and the whisker. Here's the box, the middle 3, and then the whiskers. Can anyone tell me what's in the box? What's in the box? What's in that middle? How much of the data? What percentage of the data is in that box? Say again? 60?
It's about 3/5, right?
Nope. You got to be really careful. What's this? What's this right here? What is this guy? What was that? Q3. What percentage is below Q3? 75%. What's this guy? So what percentage is below him? So what percentage is in the middle? Yeah, the box is always the middle 50%. If any of you guys ever looked at a guide to colleges, there's like the Princeton Review of Colleges and all these different things. Anybody think about transferring? Have you looked at any information about colleges you want to transfer to? Or is it just SDSU because it's right there? I don't know. Have you guys looked at anything? Very often they'll report the middle 50% of GPAs of students at the school, the middle 50% of SATs. They want to show you the heartland of their student population, right? They don't want to show you the people out there, the people down there. They want to show you the bulk of the middle, right? To kind of tell you what's sort of normal or what, the regular average student looks like. So this is really important, this little middle piece. There's something called the inner quartile range, which is just Q3 minus Q1. So that's the kind of thing that's reported very often if they don't give you the box plot. Has anybody ever seen something that looks like this, ever, anywhere? A few of you guys. Everybody has, I'm sure you have, believe it or not, but a few of you guys can remember. All right, so let me give you this. Let me finally shut the hell up. I want you to work on the side that says percentiles and box plots. Do not work on the other side that's got 4 groups of data. Do the side that says box plots. I need to borrow a calculator. Give me a minute. Let me get back up there, and then you can come up and grab one. Wait a second. I'm up there yet. Here, before you guys get too deep into that, if I had another box plot of data and it looked like this, well, yeah, sure, why not? Can you quickly see the differences between the data, even though we don't have a clue what the numbers were here, right? The same scale and everything, right? Blah, 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 blah. You guys with me? What would you say is the main difference between the two? Or there's a couple of main differences. Can you guys tell me something that's really obvious? How far up does this go? This goes a little bit further, right? Which one has seems to have less variation? Yeah, this is really small. 50% of the data is here, right? 50% of the people are from about 10 to about 22 or something. Bam, right? And then there's a few out there at the extremes. This one definitely has wider range, it looks like, in the middle. So if you had several of these kind of like plopped on top of each other, you can quickly compare things between all of them. So that's one immediate use of this, is just to have the same scale, several box plots. You can quickly tell some things about it. And this didn't take a long time to create. All right, go for it. Work on that. If you want to work with other people near you, feel free. If you need a calculator, come on up. Bring an ID.